So this is going on page 27. I want to talk about something that we did yesterday. You don't have to get your notes back out. We're just going to go back and talk a little bit. Because I had lots of questions on this one, okay? And went over it a couple of times because people kept asking, so I'm just doing it one more time in every class, about where did this value of n is the least value it could be is 5. So here's what I want to make sure you understand, is that n is the degree. And the degree is how many zeros you have, whether they're imaginary or real. Make sense? So if I have something to the 8th power, I have 8 zeros. They may be, half of them might be imaginary, maybe one of them shows up 3 times, there's different things that can happen. So that's what we're looking for here. Then we go with what we know. They told us that I squared of 3 is a 0. So we put it right here. We might have written them in a different order in this class, and then because of this, we know that this one also exists, right? That makes sense? All right, so then from our graph, we know that this is 3, and then -1 is 1. And because it is a bounce, we know, or that it is tangent to the axis, we know that the multiplicity of that 0 has to be even. 2, 4, 6, 8, 158, it doesn't matter, it's even. Okay, so then when we want the least possible value, without more information, I can't tell you exactly what the degree is. But I can give you the least possible number for the degree because I count 1, 2, 3, and then since this has to be even, the smallest it could possibly be is 2. So I take these 3 and add 2 of these. That's where my 5 comes from. Okay? Are we okay on that? Any questions? All right. Then we finished up by looking at something we've done before, which is where's the graph positive and negative, right? We just formalized it with the f of x greater than 0 and less than 0. Did it graphically, by looking at the graph. Today we're going to look at what do we do when we don't have the graph? How else can we figure that out, okay? So that's what we're starting with here. And that is called solving nonlinear equalities or solving polynomials, something like that. I mean, there's different ways to say it. But here are our steps. I'll talk you through the steps, and then we'll go through the steps, and they'll make more sense. The first thing we need to do is solve f of x equal to 0. We're used to doing that. No big deal. Set it equal to 0. Then we create a sign chart. This is the part that's going to be brand new to you. It's not complicated. It's actually very simple. We're going to use it a lot for different functions, and then you use it a ton all through calculus as well. So it is something that we need to make sure we get because we're going to continue on using it. Once we create that, we're going to test values in each interval, and all this will make more sense as we go through it, but in each interval, and we just want to see if the intervals are positive or negative. I'm not going to care about an actual number there. And then I have to interpret my sign chart and answer the given inequality. This note is important. Be sure to write your answer in interval notation and think about the endpoints. Do I include the endpoints or not? And I will make sure to show you how you can wrap your mind around that. Okay? What questions we got? We good so far? You don't even know what to ask at this point, I know. Okay, so we look at, you can just put that back on my desk. We look at example 4 here. So the first step was to set it equal to 0. It's not really equal because it's an inequality, but it's set to 0, so we're good there. And then I'm going to create my sign chart. Your sign chart's really just a number line. And your number line really just represents the x-axis. We don't care about the y-axis right now. It represents the x-axis just like a number line does. So just like you know how a number line works, make sure your numbers go from least to greatest. That's very important, okay? So here's our number line for our sign chart. What we put on this are our zeros, okay? I have 1, 2, 3 zeros that I'm going to get out of there. They do not have to be spaced accurately. It's actually better if you just kind of space them evenly for yourself. Don't worry about whether or not it's accurate for an axis, okay? So I know I'm going to do 1, 2, 3. I'm just going to kind of space them out evenly. But then I got to make sure that I put them on there least to greatest. So of those 3, the smallest is -4. Then I have -1. Then I have 3. Okay? Make sense? We good? All right, so if I had the graph, then I'd be able to tell you between the zeros whether or not the function is positive or negative by looking at where the y values are, right? Well, that's what we're trying to figure out without actually having a graph. So what I'm going to do is I'm going to pick numbers that are in these intervals and test them. So between negative infinity and negative 4, I got to pick something. We don't need to go crazy. Let's pick negative 5. And I'm going to substitute it in here. But all I care about is the sign. I don't care about the actual value. So if I take negative 5 and put it in here, negative 5 minus 3, is that positive or negative? Negative. Okay. And then negative 5 plus 1 is positive or negative? Negative. And then negative 5 plus 4 is negative. So I get 3 negative numbers. And when I multiply negative times negative times negative, what do I get? Negative. So whatever the value is, it would be negative. And that's all I care about right now. So now I know from negative infinity to negative 4, the function is negative. It is below the x-axis. Okay? So now I pick something between negative 4 and negative 1. Let's go with negative 2. Negative 2 minus 3 is negative. Negative 2 plus 1 is negative. Negative 2 plus 4 is positive. So negative times positive is positive. Between negative 1 and 3, I can pick 0. If you can ever pick 0, pick 0, because it makes it pretty easy. 0 minus 3 is negative, and then that would be positive, positive. And when I multiply negative times positive, I get negative. Then from 3 to infinity, and don't forget the ends, because some people will just like do the middle and forget that you have to go from the infinity interval. Let's pick 4. 4 minus 3 is positive. 4 plus 1 is positive. 4 plus 4 is positive, so that one is positive overall. So this tells me where my function is positive and negative on which intervals. Everybody okay with that? Now, I'm going to go back and look at what this was actually asking me here. So it says I want my function to be greater than 0, which means I'm looking for it to be positive. Will I include my zeros? No, because there's no little line underneath there. So one thing to help you, you might want to put open circles here so you can remember, just like on a number line, I'm not counting that. But I want it to be positive, so the positive is here and the positive is here. So I'm going from negative 4 to negative 1, not including, starting back over at 3 and going to infinity. Okay. What questions do you have? We all good so far? All right. Let's try another one. Here's my number line. What? Did I do something wrong? Or you had a question, I was ignoring you? I'm so sorry. Yeah, go ahead. You can choose, yeah, so when we had between negative 4 and negative 1, I chose negative 2. I could have chosen negative 3. I could have chosen negative pi if I wanted to, right? Because when I do that, all of those values are going to have to be positive. So I'd get a positive value no matter what. Because I don't care about what the actual number itself is. You with me on that? I just want to know if it's positive or negative. Does that answer your question? Good question. Yes, ma'am. So you get this part. Is that what you're saying? But how did we go from here to here? Okay. Because then we go back to this, and I want my function to be greater than 0, which means where is my function positive? So I go back to this, and I look at any place where I put that it was positive. Does that make sense? And that's why I circle those. Because, like, I write down those little ones because I'd probably forget which ones I wrote down if I didn't, especially when you get a bunch. And then once you multiply it out, I circle them because I'm like, those are the ones I'm looking at. And so because I want it to be positive, I'm looking at the ones that are positive. Okay, good question. Yes, ma'am. Okay. Uh-huh. Well, because negative times a negative is a positive, and then a positive times a positive is a positive. Just your basic multiplication, just your basic integer rules, nothing fancy. Just literally, because again, it doesn't matter what the number is, but if you multiply two negative numbers together, you're going to get a positive number. You multiply that positive number times another positive number, your number is positive. You don't need the numbers, no. But I will tell you this, here's a little disclaimer. If I ever give you any of these in Delta Math, or you ever do them at any point anywhere, for some reason, because you know Delta Math does a great job of showing you, like, this is how you do it, whether you get it right or wrong or whatever. But sometimes they go off the rails, and I don't know why. When they do this, whatever number they pick, they actually find the values and then multiply and get these big numbers and look to see if it's positive or negative. Those numbers don't mean anything, so you don't have to do that, just so you know, if you see it in Delta Math. So sometimes Delta Math does things weird. Those are great questions. What else we got? We good? All right, so let's try this one. I've got, so I have 2 zeros, so I only need 2 hash marks here. And then I got to make sure I put them in order. So this would be -2, and this would be 5. Okay? So I have, even though I had 2, I have 3 intervals, right? Because I got to do from -infinity to -2, from -2 to 5, and from 5 to infinity. So from -infinity to -2, let's go with -3. Okay? So if I put a -3 in here, -3 plus 2 is negative, but when I square it, what happens? It's positive. And actually, anything I put in here, since I'm squaring it, is going to end up being what? Positive. Okay, so that one I don't really even have to overanalyze anymore. And that comes in handy, especially if I have a whole bunch of intervals. Just like, that's positive no matter what, and move on. So my first one is positive for sure. Then I'm going to take that -3. -3 net minus 5 is a negative. So a positive number times a negative number is negative overall. Excuse me. We good? All right. So now between -2 and 5, what should we pick? 0. If you can pick 0, it makes it easier. This is going to be positive no matter what. And then 0 minus 5 is negative. So this is negative. Okay? You sure you're okay? Do I need to send you a plan? No? Then from 5 to infinity, let's choose 6. So that would be positive for sure. 6 minus 5 is positive. Positive times positive is positive. Oh, goodness gracious. I was trying to erase my knuckles at the board sometimes. Okay. Positive times a positive is a positive. Okay. So now I'm going to look back at that equation, and the equation, it should be less than or equal to 0, which means it's going to be negative. And do I include my zeros? Yes, so negative and 0. Where over here we put the open circles because we knew we were not actually using them. Here, I'm going to put the closed circles, so hopefully I can write this out correctly. Okay. So then I want it to be negative. This is negative, and this is negative. Yeah, can I just combine it and go straight from -infinity to 5? Yes, because I'm including it. If I was not including it and this was open, then I would have to have 2 intervals. Does that make sense? But yes, those 2 pieces, but they connect by that 0, so we are good to just go from -infinity to 5. And do I include 5? Yes, I do. Good job. What questions do you have? Now, I'm going to draw something on here that I do not want you to do. Because a lot of times I'll say, if you want to, go ahead, but you don't have to. But don't, because then what I have seen is that then sometimes, because you're looking at your notes, which is great, but you see that, you think you have to, and then it adds confusion. So I don't want you to draw what I'm about to do in orange. I just want you to follow along with me so you can understand what all it's telling me here. Just by this, okay, and again, I don't even have a y-axis, I know a lot about what my function looks like, okay? Because I know from -infinity to -2, my function's negative, so it starts down here, right? Then I know it's negative, but then I hit this point and it stays negative, so that's where it's going to be tangent to the axis, and it's going to bounce off like that, right? And then it's going to have to turn around and go back up through that other 0 for the function to become positive. So my function looks something sort of like that. Like I have no idea how far down this comes or anything, but I can tell you that between -2 and 5, I have a relative minimum. You with me on that? Like it gives me some information about the function just by the nature of what's happening. Okay? So that's just a little FYI and where we're getting that stuff from. What questions you got? Anything? Yes, sir. Because it's negative and then it's negative. This is a 0, so I have to touch the axis. So if it's negative, I have to head towards this 0, and then since it stays negative, it has to come back down. If it was positive, it would go through it. Does that make sense? So that's how we know it's a bounce there. Okay. Any other questions? This one, so I can draw this one too. But don't do this. Okay, and these are zeros, but I have a negative, it's negative, then it becomes positive, then it's negative, and then it becomes positive, something like that. Okay, you with me? So just from my sign chart, you can tell me where your relative maximums and minimums are after we get a little deeper into this. I think it's a little too much to have you do all that at once, but I do think seeing it, you can kind of wrap your mind around it a little bit better. Okay, we good? Any questions? Awesome. All right, now I will say that I feel like, this happened, I don't know why that happens sometimes, it won't, and I can't erase it, so we just have to ignore, pretend like that's not there. This section is a lot about polynomials, so it does kind of seem like we're jumping around on content, but it's all about polynomials, but it is a little kind of randomish. And we've sort of already done this. I know you've done it in Algebra 1, and we sort of did it the other day when we looked at tables, so it's not that big of a deal. So if I'm given a table of values and equal with input intervals, that's very important, okay? Remember that keeps coming up. Got to check that. We can determine the degree of the polynomial by examining the successive differences in the output values. So instead of finding the rates of change, like I did on one of them, we're just looking at the differences. So I'm going to look here, and I look first at my inputs. This is 2, 2, 2, and 2, okay? And then that's equal widths, great. So now I look at differences here. -3 minus a -2 is a -1. -1 minus a -3 is 2. 4 minus a -1 is what? 5. 12 minus 4 is 8. Now you have to be able to add and subtract positive and negative integers to be able to do this. But so this is that's my first difference. Are my first differences constant? No. So I move on to my second differences. 2 minus a -1 is 3. 5 minus 2 is 3. 8 minus 5 is 3. So my second differences are constant, which means the degree is 2, or how else could I say it? It's quadratic, right? And these questions really in the end on the actual AP exam would be multiple choice, so just know it could say degree 2 or it could say quadratic, and I'm sure you know the difference there. So our answer here then is that the degree is 2 because second differences are constant. Okay. Any questions about that? We good? That makes sense? Yes. Oh, yes. Oh, good question. So the other day when we did that, we found these 2's, and then we did this, and we put the 2 on the denominator. That's because we were actually finding the rates of change. So if I want to find the rates of change, yes, I have to use this as a denominator. Very good question. This is specifically the differences, not the rates of change. You with me on that? So it actually makes it a little simpler. Of course, you can't tell me, we can't use that and say we know stuff about concave up and down without talking about rates of change, but we can do the differences. Okay, good. Anything else? Okay, perfect. All right, so then here we look at this. They're all 3. That's great. So all we're doing here is really just checking. They're the same, and then I don't have to use them. And then here, 0 minus a -2 is 2. Pretend like that orange thing is not there. 10 minus 0 is 10. 27 minus 10 is 17. 50 minus 27 is 23. And these are my first differences, and they are not constant, right? So I move on to my second differences. 10 minus 2 is 8. 17 minus 10 is 7. 23 minus 17 is 6. These are the second differences. They're not constant either. So I'm going to move on to my third differences. 7 minus 8 is negative 1. 6 minus 7 is negative 1. My third differences are constant. Now, if they weren't and I had to keep going, I'd need more data because then I don't have anything to compare it to, right? But my third differences are constant. Therefore, what's the degree? 3, okay? So degree is 3 because third differences are constant. And we can say, it can be said that it's the degree 3, or what else could we call it? Cubic, good. All right, yes, ma'am. Okay, good question. This being 3 has absolutely nothing to do with this being 3. Good question, because this is 2 and this is 2, and those are total coincidences that I didn't notice, but when you notice patterns, so yes, those not related at all. Good question. It's 2 because I had to do the second differences, and it's 3 because I had to do the third differences. Good question. Anything else? Alrighty. Let's flip this over. Alrighty. Even and odd functions. So, even and odd functions. That is different than even and odd degrees, okay? You can have a function that is an even degree and it not be an even function, just to be clear about that, all right? Sit up. You're missing all the fun. Come on, sit up. So even and odd functions. If I have an even function, it is symmetric over the y-axis. Visually, that's what we can look at. We have y-axis symmetry. If I reflect this in the y-axis, it's going to look exactly the same, okay? Algebraically, f of negative x equals f of x, meaning that I have this point here, that is 3, 1, and then f of negative x, or f of negative 3, equals f of x, that same 1. So basically just changing the sign on x, that's how you reflect in the y-axis, okay? So then, well, we're going to write for every xy, there is a negative xy, okay? That's how we know algebraically is what's happening, but there's another part to the algebra part of that, which we'll look at in just a second, okay? We good with that? Then we have odd functions. It is symmetric about the origin. So this is rotational symmetry, which you learn about in geometry. No, it does not have reflexive symmetry, but if my center of rotation is the origin, and I rotate this 180 degrees, which you can just turn your paper upside down. I can't turn my board upside down. The graph looks exactly the same, okay? And we're going to have to maybe pretend on a point here because these don't come out very nicely as far as signs go. We're going to pretend like this point is 2, negative 2. I know it's off some, but we're just going to pretend, okay? So let's just, it'll make it easier. This is 2, negative 2. Right? And see, g of negative x equals negative g of x. So then negative 2, positive 2. Basically, you have to change the sign on both of them. So what we can write in words here would say for every xy, there is a negative x, negative y. That's what gets that rotation, is you change the sign on both. Okay. What questions you got? We good so far? All right. Let's look here. We're going to determine if the following polynomials are even, odd, or neither. And so we do that by substituting in the negative x. So this will be h of negative x. That's equal to 2 times negative x to the 4th minus negative x squared plus 5. First step, 0 work, you substitute it in. Okay? Second step, we clean it up. H of negative x. So this is 2 times, what is negative x to the 4th? X to the 4th, right? Minus negative x squared is x squared. And then plus 5. So you substitute it in, then you clean it up. Then you ask yourself, is what I have here exactly what this is here? This time, this answer is yes. And this represents h of x. So that means that h of negative x equals h of x. So what kind of function is it? Even. So it is an even function. Okay? Yes, we see that it has an even degree, but that doesn't guarantee that it's an even function. Okay? What questions we got right now? We good? All right. So then, going to do the same thing here. K of negative x. That's equal to negative x cubed plus 3 times negative x minus 1. I substituted it in. 0 work. Then I clean it up. K of negative x equals, when I cube a negative, it stays negative, so that's negative x cubed plus, actually that would be minus 3x minus 1. So does this match this exactly? No. So when the answer is no, then we have another step to do. Doesn't guarantee anything one way or the other. Now, because the answer is no, we factor out a negative. And then this is going to leave us with x cubed plus 3x plus 1. Then I reevaluate. Now, does this, what's inside the parentheses, look exactly like this? No. It's close, but look at this, right? If the answer was yes, let's say that this was a minus and they were identical now, then k of negative x equals negative k of x. But this is not k of x. So this is going to be a neither situation. Okay? Everybody okay with that? You see how that works? What questions you got? All right. I know it's getting down to short on time, but we can finish these two because these will go fast. On C, do we think this is even, odd, or neither? Even. And that's because, look, my 1, negative 3, and this is negative 1, 3, or close enough, right? So I can say that xy maps to negative x, negative y. That makes it an odd function. Yes? Okay, what do you think about D? Even, odd, or neither? Neither. It has symmetry, but not with the y-axis, so this is neither. Good. What questions you got?